double sideband suppressed carrier modulation. And the name indicates it is having two sidebands, but there is no carrier. The same point. Because of suppressing the carrier, we can say up to 67%. Let's see. Let us assume message signal. Let us assume message signal M of t, and the carrier is said C of t equal to AC cos 2 pi fct. Then the DSBSC modulated signal is as DSBSC signal is multiplication of M of t with the carrier, that is simply AC into M of t into cos 2 pi fct is the expression for DSBSC, the general expression. If you observe the general expression, we have the actual modulated signal only. We don't have any carrier, students. Because of suppressing the carrier, what is the advantage you will get? The transmitter power will be saved. That is the point. Clear or doubt? Now, suppose if I assume M of t having a spectrum like this, from minus omega m to plus omega m, then this is M of f. Then the DSBSC signal spectrum is, observe, if you see the message, if you see the actual modulated signal, what is the term we have? Only one term, that is multiplication of M of t with the cos function. I told already, any signal multiplied with either cos or sin, what happened? The spectrum of M of t shifted to its frequency. So, it is shifted to Fc as well as shifted to minus Fc. So, this will be the minus Fc plus omega m. This will be the minus Fc minus omega m. Now, what is the band above is called upper side band, below is called lower side band. Below is lower side band, upper is called upper side band. So, if we observe the spectrum of the DSBSC modulated signal, we have lower side band and upper side band. We don't have any carrier frequency component, students. Let's analyze the bandwidth. Is there any improvement in the bandwidth? Highest frequency component minus lowest frequency component. Highest frequency component, this value, Fc plus omega m, this value, Fc minus omega. Highest frequency component is Fc plus omega m, lowest is Fc minus omega m. So the bandwidth is 2 omega m, still 2 times the message signal bandwidth. So there is no improvement in the bandwidth, but because of suppressing the carrier, we can save the transmitter power. Getting the point, Shiva? Or any doubt? DSBSC modulation. What is a singleton modulation I told? If suppose M of t equal to Am cos 2 pi fmt, means message signal is having only single frequency component, the modulation corresponds to that message signal is called a singleton modulation. I told. What is the carrier set? C of t equal to AC cos 2 pi fct. Then what is the general expression for DSBSC modulated signal we got? AC into m of t into cos 2 pi fct. What is the m of t? Am cos 2 pi fmt into cos 2 pi fct. Simply I substitute the m of t value, students. It's a cos A into cos B formula now. Apply. Then we will get AC, but 2 is not there. So AC AM by 2 into cos A plus B, that is cos 2 pi FC plus FMT. AC AM by 2 into lower side band. Cos 2 pi FC minus FMT. FC plus FM is called upper side band. FC minus FM is called lower side band. So you can observe in the singleton DSBSC modulation also, we have only the side bands. There is no carrier. So it's a double side bands. Upper side band is there, lower side band. So 2 side bands, but there is no carrier. This is the singleton DSBSC expression. Remember, this is a general expression. This is for single. I am directly writing the DSBSC signal spectrum. If we observe the first term or second term, both are cos functions only. For the cos functions, how the spectrum? Let me take this is FC. For the cos functions, how the spectrum I told? We have the impulse at its frequency. What is the frequency of the first term? FC plus omega, FC plus FM. So we have one impulse at FC plus FM. I will write the strength. Wait. The same thing will be in the negative side. So minus FC minus FM. We have the impulse. What is the next component? Next one is also cos. Cos means we have the impulse at its frequency. What is the frequency of that one? FC minus FM. This side also same. FC minus FC plus omega. Apply the negative sign. If we observe both are having same amplitude, so the strength of these impulses also same. What is the strength I told? Take its amplitude, divide by 2. Amplitude is by 2, another 2 means by 4 you will get. That is the spectrum of the singleton DSBSC modulation. In the spectrum of the singleton DSBSC modulation, we have upper side band and we have lower side band. There is no carrier component. What is the bandwidth? Bandwidth is highest frequency component minus lowest frequency component. That is FC plus FM minus of FC minus FM. That is 2 FM. That is 2 times the FM is of course message signal frequency. So for the as well as AM, the bandwidth requirement for FM also same, students. The expression of the singleton DSBSC modulation signal, it's AC AM by 2 into cos 2 pi FC plus FMT plus AC AM by 2 into cos 2 pi FC minus FMT. We have only side bands. Of course, the first one is the upper side band, the second one is the lower side band. So the total power in the DSBSC is upper side band power plus lower side band power. That is the total side band power. We have only side bands. Of course, the power of the here upper sideband or lower sideband both are same. Why? Because both having same amplitudes. How to calculate the power for? It's a RMS value whole square. What is RMS value? Take its amplitude divide by root 2. You will get the RMS value for either sine or cos and square it into 1 by r. So what you will get? AC square AM square by 8r. Substitute the value. So you will get the total power is upper side band is AC square AM square by 8r. Lower side band also same. AC square AM square by 8r. So what is the total power you will get? AC square AM square by 4r is the total power. Yes. Now tell me, what is the efficiency value? Go with the basic concept. One means 100%. Efficiency is, it gives the total sideband power in the total power. Of course, in the DSBSC total power is nothing but total sideband power 1. So, efficiency is 100% for DSBSC modulator. DSBSC modulators. Completed. Okay. Write one question. Just to understand the terms. Write down. An audio signal given as given as 15 cos 2 pi into 1500 t. An audio signal given as 15 cos 2 pi into 1500 t is DSBSC modulated by a carrier of 60 cos 2 pi into 5 zeros t. Determine all the parameters of DSBSC signal. Determine all the parameters of DSBSC signal. Determine all the parameters of DSBSC signal and draw the plot. Determine all the parameters of DSBSC signal and draw the plot. Okay. An audio signal means this is the message we are going to modulate. This is the carrier signal. So what is the AM amplitude? 15 volts. What is the frequency? 1500 hertz. What is the AC value? 60 volts. What is the FC value? 10 to the power 5. Or I can write 100 into 10 cubes, so 100 kilo hertz. Find all parameters means start with the bandwidth requirement. Bandwidth is 2 times the message signal frequency. That is 2 into 1500. That is 3000 or 3 kilohertz is the bandwidth needed. Of course, we already know efficiency is 100%. Next, total power requirement. AC square, AM square by 4R. AC value given 60 whole square, AM value 15 whole square divided by 4 into R value not given. So take to 1 ohm the normalized value and calculate. You will get 202.5 kilowatts. We want to calculate the upper sideband as well as lower sideband. Will have both will have same power. What is that value? AC square AM square by 8R. Then we will get 101.25 kilowatts. This is the FC. We have one frequency component FC plus FM. FC is 1000 kilo plus FM is 1500 means 1.5. So 101.5 kilohertz we have one impulse. The same thing in the negative side, that is minus FC minus FM, that is minus 101.5 kilohertz. Next component is FC minus FM, that is 100 minus 1.5, that is 98.5 kilo, that is FC minus FM. The same thing will be in the negative, multiply the negative, that is minus 98.5 kilo. I already told all will have same strength. Strength value is AC AM by 4 I told. AC is 60, AM is 15 by 4, of course 225 volts.